Measuring the angle of deflection, a static mode of operation for microcantilever sensors. This microcantilever is fabricated with a structural silicon nitride layer topped with a thin film of gold, and then a functionalized layer containing a target binding material, or probe. The probe contains probe molecules that detect and bind to specific target molecules, or analytes, the molecule to be analyzed. In the static mode of operation, a change in the cantilever's Z displacement indicates an intrinsic stress on the cantilever. The intrinsic stress is due to a reaction between the adsorbed analytes and the molecules in the probe layer. The target analytes are adsorbed at the surface, causing surface reactions between the analytes and the probe coating. In the case of these microcantilever transducers, the reaction between the targets and the probes could result in mechanical stress of the surface layers. Because the layers are attached, the cantilever either expands, bending down, or contracts, bending up. In an array of microcantilevers, different probe layers and different analytes cause reactions unique to each probe and target. Lasers aimed at the surfaces of the cantilevers deflect off the surfaces at different angles, depending on the amount of adsorption and bending of the cantilever. A position detector made up of photodiodes detects the angles of deflection and changes to these angles as they occur. Putting it all together, here's an illustration of a static mode chemical sensor array, or CSA. This CSA detects several different analytes simultaneously, then identifies the analytes and determines relative amounts. To determine the type and relative amount of each analyte, the CSA depends on the reactions at the surface of the cantilevers, the amount of Z displacement, and thus changes in the angles deflected off the cantilever surfaces. See if you can come up with some applications for this type of MEMS sensor.